So guys, in our previous video, we have already seen how to do feature selection, and I did feature selection based on correlation. And here we have also set up any threshold value. Many people may be having confusion. What about the negative correlation? So here we have specifically taken some absolute value so that both positive and negative correlation will be able to handle it. Then we did feature scaling or standardization. And then after doing the feature scaling and standardization, we could also see with respect to the box plots. Now quickly, let's go ahead and try to start applying different models, and we'll start with linear regression, and then we will go with lasso regression, then ridge regression, then elastic net regression. But as you know, while lasso ridge is basically used to basically overcome overfitting and making sure that the feature selection process also happens, right? So that we have already discussed in the theoretical intuition. So in order to apply the linear regression model, already we know that we have seen from our previous project. So I'm just going to write from sklearn dot linear model. It should be linear model or import linear regression. And again, guys, whenever you want to check about anything about the model, please make sure that you check the documentation page, or here also you can basically use like this reg is called to linear regression, and here you can also press shift tab to check out all the information about this model. Entire description information is also given. Otherwise, just go and search for sklearn linear regression, you'll be able to get it. Okay, so here now I'm just going to write linreg dot fit on my transform data set. So here I will say xtrain scaled, and this will basically be my y train, right? And then what I'm actually going to do, I'm also going to compute the mean absolute error. So let's me go over here. Let me write from sklearn dot metrics import means absolute error. You can also take mean squared error, that is not a problem. So mean absolute error on after we did the fit, and here what I'm going to do, I'm also going to compute my ypred, and this will basically be on my. So if I really want to find out what is ypred, I'll just go and write xtest, and I will get it. And there I'm actually comparing with respect to ypred and ytest. I can also make sure that I can compute the R square score. So from sklearn dot metrics import R to score, right? So here you can basically see that score is equal to R2 score with respect to my y test comma ypred. Okay, and then I can print my mean absolute error comma MAE, and similarly I can print my score, that is nothing but R2 score, and this will basically be my score, right? Let's see, linear dot predict. I need to write dot predict. How can I miss this? I'm not going to cut this part, but anyhow you will be able to see it. Perfect. This is it. What I'm actually going to do apart from this, and here you can also see that, okay, I'm testing with y test and ypred. Y test and ypred, white is basically coming as negative. Let's see, y true and y test, ypred, perfect. Anyhow, we're getting an R2 score of negative value with respect to our X train and Y train scale. The reason why it is coming as negative, because I did the prediction with respect to X test data, so I'm just going to make it as X test scale. Now here we can see that the R2 score is 98%, which looks absolutely perfect and good. One more thing, what I'm actually going to do is that I'm just going to scatter this plot with respect to y test and ypred, and obviously you know that if this follows if the y test and ypred follows a linear relationship, this is a very good model. So yes, it is a good model, but there are scenarios that whenever we try to implement linear regression model, right, there are chances that it may be overfitting the model. Right now what I'm actually going to do after this is that let's go ahead and apply the ridge regression or lasso. I will start with lasso regression. Okay, lasso regression, and here lasso regression model, we are going to apply it. uh, and I'm just going to copy the same thing and just change some of the things over here, and here I'm just going to apply lasso, I'm also going to discuss about a lot of parameters, which is called as lasso CV. But right now, let's focus on lasso and let's see that how we can apply this. All I have to do is that copy and paste it over here, initialize lasso over here, and then copy and paste, copy and paste. And I'm actually doing it on X2 and Xscale. Then if I probably try to execute it, here you'll be able to see that I'm getting an R2 score of 0.949 and mean absolute error of 1.13. Before, the mean absolute error was 0.54. But just to understand, since the R2 score is get reduced, that does not mean that the model is not performing well. It may be overfitting, the previous model may be overfitting, and try to fix that particular overfitting itself, right? And similarly, I can also apply for the ridge regression model. So I will also show you that specific part. Okay, let's make it as a markdown. And again, I'm just going to copy this entire thing, paste it. We can just do the copy and paste, and this will basically be my ridge. Yeah. So ridge will be there. I'm just going to copy this over here. This will be ridge, and the ridge dot fit dot predict, right? So quick changes, and let's go and execute it. Here you can see that I'm again getting 98%, 5.6. It may be helping us to remove all the features that are not that important with respect to the ridge regression model. But obviously, you know the importance of both lasso and regression and ridge regression. If you probably want to combine both of them, then obviously you need to have something called as elastic net, right? So here I am just going to write elastic net, right, regression. Okay, and just let's go ahead and copy paste the same thing. It's simple, right? Copy and pasting, but yes, for the first time you have to do it elastic net, right? And then I'm just going to copy this. I'm going to copy this. This will be elastic, right? And then I'm just going to copy this over here. I'm just going to copy this. Everything looks fine. Let me go ahead and execute it. Now here you can see that the R2 score is 87% and 1.88. But again, understand guys, elastic net has some parameters like alpha, L1 ratio. This is just to make sure that how much L1 norm you want to take, how much importance you really want to give on the feature selection, or how much importance that you really want to give in the overfitting, right, side. So L1 and L2 norms are all about this. Now in the upcoming video, what we're going to do is that we're going to play with all these parameters. We'll do cross validation. Now when I say cross validation, what I'm actually going to do is that, see, forget about linear regression, but if I go over here, right, and if I probably import over here as lasso, and if I make this as lasso CV, so lasso CV is specifically used for cross validation, right? So here you can basically see that if I write lasso CV and if I press shift tab, here we are going to use lasso CV for doing the cross validation to find out the alpha values. Because over here, if you see in lasso, right, if I press shift tab, there will be some alpha value, and this alpha value can be selected to some kind of hyperparameter tuning. And one hyperparameter tuning is called as cross validation technique, right? So in my next video, I'm going to basically do cross validation and select the best parameters that we can. So I hope you were able to understand it, and yes, I will see you all in the next video.